Mic test, mic test. Everything is, I think everything looks good. Wow. I know, guys. Hey, what's up? Long time since I've streamed. Just kidding. It's been like what? I think it's been, I think it was like what, Tuesday since I last streamed. Could be wrong, but it has been a little bit. I just needed a little bit of a break. Um, and just trying to learn new things, trying to expand my repertoire. And I was just like thinking to myself, what are way how am I like cuz we talked about in the previous streams, we talked about layer 3 and layer 2 um in the networking essentials. Let me pull that up. Um so we talked about last stream how um layer 3 routing, and we talked about how gateways, the routers learn how to forward packets. We learned how how routers know how to send the packets, right, to the destination, and that's through its routing table. And um, we talked about how gateways learn new routes either dynamically or statically, right? Dynamically meaning the routers are speaking to each other and sharing each other their own individual routing tables, and then there's statically assigning networks, like the administrator, the network administrator can manually input networks, right? They can put in the information, and then the router can learn it that way. Um, that was the last stream, and I think uh, that was chapter 7, and then in chapter 6, we learned about ARP. The reason why my internet's a little slow, or maybe a little bit, um, yeah, I guess slow, is I'm using proxy. I'm using a proxy, so it may be a little slow. But we learned about in chapter 6, we learned about encapsulation, and not only encapsulation, but we learned how the layer 2, the frames, right? The frames are encapsulated and what's encapsulated in it, right? We talked about the preamble and the start frame delimiter. We talked about how there needs to be a destination MAC address and a source MAC address. We talked about the type, um, and the type is just what kind of message is it going to be if there is the need for this portion, right? If it's going to be IPv4 or IPv6. If it's going to stay layer 2, then this is irrelevant. And the type of data, and then the frame check sequencer that just makes sure nothing is messed up, right? And so we talked about that, and we talked about the logical addressing and physical address. Um, no matter where you are, right? Doesn't matter where you are in the world, your MAC address, right? Your individual MAC address, right? And I'm not talking about uh, whatever, right? I'm talking about your laptop, or wherever you go, to the coffee shop, to the library, to your friend's house. That MAC address is always going to stay the same. And then we talked about logical address, your IP address, that can change, right? I can go to a coffee shop, and if the coffee shop's network is 192.168.20, in my house, the default network is 192.168.1.0, then I have two different, my logical address has changed. So we talked about that. We talked about access layer, right? This is where your local area network, right? The access layer is your LAN, right? And then the distribution layer we talked about is routing, right? Um, how if my machine needs to contact another machine outside of my network, it's going to be the distribution layer is going to be taking care of that, right? So I was thinking, so we talked about all of this, right? And in the time that I was like not streaming and trying to just learn more and work on myself, right? And I know that I said like, there should be a way, or I know that some people want to see more ethical hacking. Um, and so, I was actually on TryHackMe, and I was just, going through certain labs and stuff like that, and then I stumbled upon this NMAP chapter, right? And you guys have seen me NMAP before, but the reason I'm bringing, the reason I want to use this portion, and it's the, excuse me, the NMAP live host discovery lab, and I believe it's free. Yeah, this is a free room, so anybody can do this, right? So you at home can go on Try Hack Me, type in Nmap Live Host Discovery, and do this along with me, right? But I was going through this lab, right, and I was reading through it, and I'm like, oh my gosh, like this literally this literally is what I just talked about and went over. We talked about ARP. We talked about ping, ICMP. We talked about subnets, right? We talked about subnets. Um, and I thought to myself, we learned all of this, so why not use um, some ethical hacking tools like Nmap and another one called Wireshark, right? You guys seen me use Wireshark before. So those are the two tools that we'll be using today um, to learn a little bit about ARP and ping. And I think it'd be a great way to show in a real world what the differences are, right? The differences between ARP and ping, layer 2, layer 3, and also show you a little bit of ethical hacking. I'm actually going to be ethically hacking my own network. So we'll be able to see all my family who's on my network will be able to see their devices. Um, wh- I, I w- I'm not sure if I'm gonna show the Wireshark packets. I didn't double check to see if my, well, technically speak, well, we'll see, we'll see. Layer 3, um, as long as it's not showing my public IP address, I'm gonna just double check and make sure a little bit later. But yeah, I wanted to incorporate ethical hacking tools with networking. That way to just show you like a big picture, right? So without ado, let's do a little bit of review. Okay. Well, let me talk about Nmap before we even start, right? What is Nmap? Nmap is short for Network Mapper. It's free. It's an open source tool, meaning that you can go out and download it. Um, if you download it for Windows, it's going to be ZenMap. And basically, it's just running scripts. It's a tool that runs scripts, and you can pretty much detect live hosts on your local network, or you can scan public networks, right? And basically, you can find out open ports, try to find vulnerabilities in the network, and then try to exploit them, right? Nmap is very, very powerful if you know if you know how to use it, if you know what you're doing with it. So let's review. We talked about earlier in this course network subnets, right? What is a subnet? And a subnet is just the ID, right? It's just gonna it just identifies the machine's network, right? And we'll get a and I know that we didn't get deep into it. We will later on, I believe. Um, I don't know exactly which chapter. Um, I think it's gonna be chapter 10 to be honest, or maybe chapter 9. I'm not sure, but we haven't really dove into it yet. Um, but subnet masks, what you need to know for now is subnet masks. I give the IP. It gives it identifies the network portion of the IP address. Um, a common a common subnet mask would be 255.255.255.0, and the proxy server is okay. Whoops. Let me just type in subnet masks. How about that? And I don't have access. Okay, cool. Okay, well, let's use this for an example. We'll just use this graph, right? You saw me type 255.255.255, right? Right here. Actually, they have it up. And so they talked about 255.255.255.0. These three 255s, that is the network portion of the IP address. And the 0, that's going to belong to the host, right? So, for example, in network A, this 24 represents 255.255.255, meaning that the network portion of network A is going to be 10.1.100. This is the 10.1.100 network. And I know this because of the preface value of 24. Preface, prefix, I think it's prefix value. It's not preface. Prefix value of 24. Um, so now that we know a little bit of information now, if it was if it was a subnet mask, a prefix of 16, right? So we learned in IP addresses are 32-bit. IPv4 addresses are 32 bits, right? 4 octets equaling 8 bytes or 8 bits, or excuse me, what the heck am I saying? 8 bits equal 1 byte, and 1 byte is 1 octet. You need 32. Wait, am I just tripping myself up? I think I'm tripping myself up. 30. Okay, let me start all over. I don't. I, Let me just start all over. IPv4, 32 bytes. You know what? There's only one way to find out. Let's just 32. Okay, it's a oh my goodness. 32 bits. Okay. Jeez. I said bytes. 32 bits. 32 bits meaning 4 bytes, right? Because 1 byte equals 8 bits. So 4 bytes and an octet that we haven't covered yet. So each of these portions of the each, like this 255, that's 1 octet. This 255 is 1 octet. This 0 is an octet. This 0 is an octet. We'll go over that a little bit later, but for just purposes of learning subnets right now, just to introduce, um, if this was the prefix value of 16, right? We learned that this 24, that means 24 bits belong to the network. If you see a prefix of 16, what do you think it would be? I know you're very smart, and so I know that you already answered. 16 bits belong to the network and 16 bits belong to the hosts. And if you thought that, you're very correct. Um, and we'll learn why there are different subnets and what bits dedicated to the network and bits dedicated to the host. We'll talk about that later on in chapter 10 or something like that. We'll learn why there are different subnets and what do the subnets do. But just to give you a little bit of information, the less bits dedicated to the network portion, right? The less bits means there can be more hosts. And the more bits dedicated to the network portion means less hosts. So with a subnet prefix of 16, this network B, this 10.2 network, has a potential of having, you can have up to 65,000 hosts. Around, like, I think it's a little bit more than 65,000, but just around 65,000, right? And then with the subnet, this network A, with a subnet mask of 24, you're going to have around 250 hosts. I think to be exact, it's 254, but one um, to be exact, Zach, 256, but you have to subtract one automatically for the default gateway, and then one for your loopback address, I believe. So we got the subnet mask portion, right? We talked about the subnet, and then we talked about ARP, right? And we talked about how ARP is a layer 2 process, right? It's a layer 2 process, meaning that if it needs to go to a different network, you're out of luck. ARP can't help you there. So they're going to give us a little diagram. It's pretty neat. Okay. So we talked about ARP and we talked about what ARP does, right? ARP, address resolution protocol, and we talked about what it does, why we do it, right? Let's first, for example, computer 1 has the IP address for computer 3. Let's just say that computer 1, right? Whoever uses computer 1, they know the IP address of this computer 3. But the computer doesn't know the MAC address, the physical address, right? So what is it going to do? It's going to send out an ARP request. And the ARP is going to be broadcasted, right? We talked about broadcasting, and this computer is going to broadcast out in an ARP request, right? It's a request. Who has the IP address, or I mean, yeah, who has the IP address of computer 3, right? Let's just say 192.168.1. Who has that? And if computer 3 has that IP address, 192.168.10, right? Or whatever that IP address is. Everybody in the network gets the ARP request, but only the device that has the associated IP address that computer 1 is looking for is going to send out a reply. Everyone else just drops it because it has nothing to do with me. This is not me. This has nothing to do with me. I'm gonna just drop it. Only the computer or device that has that IP address is going to reply. So just to give you an example, it's saying um, from computer 1 to computer 1, um, we're going to send out an ARP request to computer 1. Okay. And so let's do an ARP request, and it says put in data computer 6 because we are asking for computer 6 MAC address using. Okay. So I wonder why it's saying from computer one to computer one. Anyways, let's send out this packet, right? Let's send out this. Technically speaking, it's a frame, not a packet, but you get it, right? Bam, bam. Nobody replied. Right. Why? Why did nobody reply? Computer 6 is here, so why did the ARP not go over here? Remember, ARP is a layer 2, and anything that passes the router is going to involve layer 3, and ARP is not a layer 3 protocol, so nothing happened. Nothing happened. But let's say right? So now let's change it to computer 4, and they want us to do computer 4 to indicate it is a broadcast. Okay. Let me just see what would happen if I just send it out. Okay. What would be the difference if I did computer 4 to computer 4? I just want to see. What would be the difference? Let me see. And then computer 6. No space. So it's the same thing. I don't know. I have no idea why they made us do that. I have no idea why they made us do that. Okay, but we saw in this example, computer 4 send out an ARP request, and again, it's a broadcast, right? So broadcast it out to the router, but the router drops it. Broadcast it out to computer 5. Computer 5 dropped it. And computer 6, because it is the computer that computer 4 wanted to ARP request to, computer 6 replied. And what is computer 6 replying with? Computer 6 is replying with its MAC address. And then that way it fills up, um, both computers fill up their ARP table. The switch also is going to build up its ARP table, its MAC table, ARP table, MAC table, right? So all these devices here, they all filled up their MAC table, so that later on, if they need to communicate, they don't need to ARP. They already know. And we talked about the MAC table probably resets like every, I don't know, like 10, 15 minutes. I could be wrong. I mean, it depends on what you configured it, but generally, I think it's around like 15 to 20 minutes they reset. But again, we have to realize that all these things, right? ARPing, pinging, all these things that are happening simultaneously are happening in the bam, 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 like less than milliseconds, right? It's amazing how computers work like this, that they work so bam, 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 just sending off rockets. It's pretty cool. So that's a live demonstration of ARP, and I think that was pretty cool that we got to see like how does ARP work, right? Um, so you probably want to see. All right. Well, Moses, you talked about you're gonna use some ethical hacking tools, um, and I will. I will. I told you I'm going to hack my own network, right? And I'm gonna be using a tool that's called NMAP. All right. So, okay. So with NMAP, you always want to, if you want to use NMAP, you gotta type in NMAP, right? And in this portion here, they're saying you can, so let's just go over this, right? So with Nmap, you can specify and give a list of addresses you want, right? So they said like your local machine, scammy.nmap.org, example.com, google.com, facebook.com. That's like if you listed each website, Nmap would go through those websites, right? So you can give it a list of websites. You can also give Nmap a range. of IP addresses, right? So in this example, they said NMAP 10 10.10.12.15 dash through 20. So this command right here, whoops, this command right here, maybe if I can zoom it out, make it a little bigger. This command right here, mmap 10, 10, 12, 15 through 20, that's going to scan, you bet, you got it, 15, 16, 17, 18, 19, 20, right? It's going to scan 6 IP addresses. And then we talked about subnet masks, and we talked about the larger the network portion of the sub. If the subnet mask has a larger portion of bits dedicated to it, that means less hosts, right? So we talked about this is a funky one, subnet mask 30, right? 30, meaning that there's only gonna be 4 IP addresses to scan. And then you can create a list, right? And then you can type in the command nmap flag I capital L. You can give it that, and and then give it the list, right? In this example, they created a text file called list of hosts. And then the cool thing is the really cool thing that nmap can do is nmap can actually scan the network without actually connecting to the networks. Like it can scan without scanning. Like it's like a light tap. Like, are you there? Oh, okay. But they're not whoever they tapped won't know it. And also, what's really cool about that is that when it does that, it's also going to try to reverse DNS and get the name of the device. So just to show you, right? I'm going to ethically hack my own network. It'd be probably nice if I actually knew my corrupt history file, home.z shell history. Okay, that's fine. I'm probably looking into that a little bit later, but I have config. I'm in the 192. My network is the 192.168.1220 network. So I'm going to copy that. I'm going to paste it, right? And then I'm going to give it the subnet mask 24. And remember, 24 means about 250 something hosts, right? So let's go ahead and nmap again. Nmap is scanning without scanning, right? And it's done. And look at this. There's there's my device, right? And the cool thing is that it also provides it in numeric order, right? So of course, by default, okay, by default, my gateway is 192.168.11, right? That every I would say pretty much most home networks, their gateway is probably going to be the number one host. The new host files router.home. This 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 device that has taken the 192.168.18 IP address, new host. Um, it's either my DHCP. To be honest, it's either going to be my I think it's going to be my DHCP server or my DNS server. One of those two. I'm not sure, but as you can see, there's a lot of empty addresses, right? Like I don't have 200 devices to plug in all these IP addresses, but you'll see there's a desktop that took the 159. There's another desktop at the 183. There's my brother, him and his PC and his iPad. Um, but you see, right? You saw like these are everyone in my network. Technically, I just hacked, or you know, got a little bit of information on them, and I have their IP address. And you can see this is my device right here. So yeah, that's pretty neat that you can. And the great thing is, again, I did this without actually having to scan these devices. I just tapped it. It's pretty much like a tap, and just seeing is there who is in my network, and nobody's gonna know that I just did this. This is gonna be the last, and yeah, this is I think this was gonna be the last part of it, and then because I didn't want to make this like a long stream, I just wanted to make it a little bit shorter because there's a lot. There was a lot of information, right? We talked about subnet masks. We talked about ARP. I showed you a little bit of NMAP. So I don't want to introduce too many things all at once. So this probably be the last part, and then we'll pick it up probably Monday. But let's talk about the TCP/IP model and the OSI model. Remember, we talked about how important this stuff was. Um, and excuse me 1 second. So yeah, we talked about the OSI and the TCPI model. We talked about the similarities and the differences. We talked about OSI being a 7 layer versus the TCP/IP as being a 4 layer. Um, we talked about how the TCP/IP kind of gives us the protocols that are being worked with, and the OSI is more of like a breakdown. And so, yeah, link layer, data link, uh, you know, think of your, again, layer 2, think of switches, think of hubs, think of MAC addresses and NIC. Like, think of those kind of things, right? And then you have your network layer. Your network layer, think of your routers and your IPv4 and IPv6. We haven't talked uh, and ping ICMP. We haven't talked about IPsec, um, but those are layer 3 protocols. And then we talked about layer 4, TCP, UDP. TCP being more of a reliable transportation protocol than UDP. Uh, uh, we, I don't know if we talked about ports, but ports are also going to be involved in transport layer. And then we talked about application layer, and we didn't really go through presentation and session just because I mean it's very important to know those, um, but for the networking essentials, not to like it's important. Don't get me wrong, you need to know those, but in terms of networking essentials, they don't really talk about it too much. So yeah, but you still want to know those, right? Um, so yeah, let's see. ICMP has many types, right? Like, so people think, oh, because ARP is like ARP reply, ARP request, right? Um, Ping has the same thing. Ping has the reply. Ping has echo. That's their version of request, and then there's a reply. But there are. Whoops! Do not. No, 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 no. We do not want to switch the website. Oh yeah, yeah. All right, where were we? Okay. There are many types of pings, right? I don't know all these pings, okay? And thank God you do not need to know all these pings. There's an internet for that, but there are certain ones you want to know. Your typical echo reply, which is always 0. Your echo itself, the request, which is ping type 8. It would be nice to know ping type 9 router advertisement because that's for IPv6. Um, Let me see. Other ones, yeah, timestamp and timestamp reply. Those are going to be ones you would. That's type 13, type 14. Um, and Fortunately, a lot of these you don't need to know anymore because they're all deprecated, meaning they're not no longer being used or should not be being used. They should not be being used. Um, so yeah, generally you're probably going to want to know type 0. It'd be nice to know type 3 destination unreachable. There can be a lot of reasons why destination is not reachable. We talked about how firewalls can be set up and configured to just not reply at all, right? And so that could be a reason why. Um, Type 8 would be nice to know. Type 9 would be nice to know. Type 11, that's pretty good to know. Time exceeded meaning it ping like you ever heard of pinged out? Um, that's pretty much it. Type 13, type 14. Um, yeah, those are would be nice to know. And again, you don't need to know all of them by heart, thank God. But it would be nice to know a handful of them, right? But in for our learning purposes, we're going to be using type 8 and type 0. Um, if you want to ping a system on the same subnet, an ARP query should precede the ICMP echo. So what does that mean? If you're going to ping someone in the same network, an ARP reply should go out first, and then a ping will go out. That's basically what it is. Uh, Although TCP and UDP are transport layers for network scanning purposes, a scanner can send a specifically crafted packet to common. Okay, so we'll learn about that in the next stream. But today, let's just finish this off with from computer 1 to computer 3. Let's do a ARP request. Oh, a ping request. I'm sorry, ping request. And let's send it out. Okay, so notice how an ARP was sent out first, and then the ping. Did you guys see that? I'll reset it for you one more time. And I wish I could make this bigger for you guys, but unfortunately I can't. But let me try it so let me do it one more time. Notice again, right? Let's assume I know the IP address of computer 3, right? So I want to ping computer 3. Let's say I want to ping computer 3. But I don't know. But what if my computer doesn't know computer 3's MAC address? It needs to send out an ARP, right? So it makes sense that this ARP broadcast is sent out. Computer 3 sends it, hey, this is my MAC. And computer 1's like, oh, okay, cool. All right, let me now send you this ping request. Even and it makes sense, right? This would make sense. I hope it's starting. At least I hope it's starting to make sense, and I'm hoping that things are coming together and being mended together. Um, so the question says, what's sent before the ping? ARP request. What does and then what does computer 1 receive before the ping? And it's an ARP response. And how many computers responded to the ping request? Well, obviously only one because that ping was specified for that particular computer, that host. So what is the name? Okay, so now it's asking us from computer 2 to computer 5, let's send a ping. And we know we can do this, right? Why do we know we can do this? We know because ping is a layer 3 protocol, right? Layer 3 meaning that it can go out of the network. Ping 2 broadcasts, they're dropped by the router. By default, they're dropped by the router. But we know layer 3 can go out the network. It can go out the network. And we're going to see this. But let's see how this works, right? This is pretty neat. This is pretty neat. Um, I mean, to me, it's neat. I'm a to me, it's pretty cool. It's a geek moment, but you know what? We should all be lifelong learners, lifelong geeks. So computer 2 to computer 5, we're going to send a ping request. Now let's see what happens. So an ARP is sent out. The router replies with its MAC address. And then the router is going to ARP request there. Did you guys see that? So we talked about this, right? We talked about this last stream, I'm pretty sure. Anything that leaves anything that leaves the network, right? If it has to leave the network, right? So what is computer 2 going to do? It's going to ARP reply or ARP request. Who has this? And the router is like, okay, this is not on the network. So it's going to reply, all right. And then so computer 2 already knows it's out of the network, but it still needs to do this process of ARPing. And we talked about how computer 2 automatically is going to in the encapsulated frame automatically going to put the MAC address of the default gateway, the router, right? And we saw that the router replied with an ARP. And so computer 2 said, okay. And so computer 2 sent the ping to the router. But notice how the router held the ping message. And what did the router do, right? Because we talked about if a router has two interfaces, right? This switch is connected to the router, this interface, and then this switch is connected to the router and another interface. We talked about how they're on two different networks, right? Because we talked about how each interface has its own unique dedicated NIC, its own unique MAC address, right? So two different networks. And so the router held the ping on this, held the ping, and on this interface, the one that's connected to switch 2, it did what? It sent out an ARP. And in the encapsulated ping, right? There's the ping, there's layer 3 information, and then there's layer 2 information, right? And then in layer 3, the router's like, all right, who has when the router sent out an ARP, it was like saying, all right, who has this IP address? And computer 5 said, hey, yo, that's me. That's me. And so what did router? So it when the computer 5 like, hey, that's me. What did router do? Router sent ping to computer 5, and then computer 5 replied, and it went to the switch, to the router, back to the. Now, what do you think would happen if computer 2 did it again? Computer 2 wants to send another ping to computer 5. Do you think it needs to do this whole process again? We talked about we talked about MAC tables, and we talked about routing tables, right? So, do you guys think that we need to do this whole process again? Well, let's see. And then this time, it didn't have to do the whole ARP thing, right? Because again, it's stored in the MAC, it's stored in the MAC table, in the routing table, right? And so that way it doesn't have to do this whole redundant process again. But then when the tables reset, right? Whenever those tables reset, then it will have to do it again. So just to do it one more time, for learning purposes, we're gonna do this one more time. Send the packet, ARP request. Router's like, okay. And then he sends it here. And then this router's like, all right, who has the IP address? And computer 5 says, that's me. So the router sends it to computer 5. Computer 5 will therefore reply back to computer 2. And then we saw because they've already established they no longer have to do this ARP thing until the ARP table resets, and then they have to do it again. So yeah, that's layer 2. I know Next one, we'll talk about layer 3. We'll use NMAP and Wireshark, a combo of two. When we go ahead and next stream, when I hack my own network with an ARP, I'm going to capture all that information. Okay, I'm going to capture all that information, right? With Wireshark, and I don't know if I really want to do that though, just because I don't really want to publicly show MAC addresses. So I'm still debating on how that's going to work. But if not, we can use this PCAP file of ARP requests and replies and try to use that as a learning uh, tool. But that's all I have today. I hope you guys learned a lot, and I hope that layer 2 and layer 3 is starting to come together. Um, it was very cool that I just stumbled upon this NMAP lab, and these things actually kind of intertwine with what we learned. So, yeah, that's all I have for today. Special announcement, special announcement. Tomorrow at 6 p.m. Eastern, I'm going to be having a cybersecurity professional stopping by my stream, and I'm going to do a little interview with him. So if you're really interested in cybersecurity and learning what the day to day looks like, um, you don't want to miss this. Like, this is really awesome. He's a really cool guy. I've known him since college. He's one of my close friends, close buddies. He's a cloud security architect for Booz Allen. So this is something that you probably don't want to miss, especially if you want to ask questions and things like that. So yeah, um, can't wait and see you all tomorrow. Love you guys. Bye.